students. So previous lecture I have explained all the concentration terms, that the representation of the amount of solute present in the solvent or in the solution, that is in the if in case of solvent, that is called solubility, means amount of solute dissolved in a particular amount of fixed volume of solvent, that is called solubility. And if there is the solution, how much portion, how percentage of solute dissolve, that is weight by weight percentage or volume by volume percentage, that all concentration terms I have explained. And similarly all other things related to the concentration term, that is also I have already explained. So I hope you properly understand all these things, and some questions also in text questions, and which is not present also in your syllabus, that is also I have explained. I hope that will be not a big deal for you right now. So now we are moving, and already you have learned that the factor affecting solubility. Students, here today I am explaining that Henry's law, that is also the factors, a part factors affecting solubility. Henry's law, what is Henry's law? Means increasing pressure, the solubility of gas increase, that is Henry's laws. Students, I already told you that factor affecting solubility of a substance, same thing explained in the Henry's law in term of pressure and temperature, means pressure and temperature relation with solubility of gas. Okay, that has explained here. In case pressure, that is Henry's law, and in case of temperature, you know, with increased temperature solubility of gas decrease. So once again I am explaining this thing, that at any given, if you read, you can see at any given temperature the mass gas dissolve by a fixed volume of liquid directly proportional to the pressure. Okay, at a given temperature means constant temperature, means if you have to write that, because when we are saying the relation between pressure and the solubility, okay, pressure increase means solubility increase for gas. Okay, temperature is equal to constant, temperature should be constant. When we are similarly when we are I will explain the relation between temperature and solubility, pressure will remain constant, okay, at a certain pressure. Okay, so students, I think you understand, and from Henry's law, that's why you can see here is a example has given that the soda water or the cold drinks, you know, when you just open its cap, a bubbles come out. Okay, because you know, the soda water can or the cold drinks can, high pressure carbon dioxide dissolve inside the liquid, and it's itself it is a just act like isolated system. Okay, but when as soon as you open the cap, what happens, inside pressure is more, because more carbon dioxide dissolve, high pressure carbon dioxide dissolve and cap fitted over there. So as soon as you release the cap, so there should be equilibrium, you know, equilibrium with outer atmospheric pressure. So to gain that equilibrium means outside atmospheric pressure is less compared to the inside bottle, so that carbon dioxide will bubble up quickly, effervescence will come. Okay, that's why as soon as you open the, not only for, you can say soda water can, or you can say cold drinks, or you can say types of wines also there. Okay, so where these types of effervescence happens, these types of condition takes place, there the high pressure gas inside that liquid present. Okay, so that is the thing, that is the thing. So what is Henry's law? Nothing but the relation between pressure and the solubility. Okay, increase pressure for gas, for gas increase pressure, solubility increase. Okay, and temperature also, you know, temperature, students, in case of solid, you know, with increased temperature solubility increase, but gas reverse, for gas it is reverse, increased temperature solubility decrease. I hope students you understand. Let's move to the next portion, that is called crystal or crystallization and crystallization. Students, by the name you can understand, crystal means a solid which has proper shape, like crystalline, amorphous, you learned the previous class carbon and its compounds chapter, that crystalline structure means a proper geometrical shape it has, but amorphous means no proper structure. So crystal, so here you will learn how crystallization happens. What is crystal, what is crystallization? Crystallization means, you know, formation of crystal is called crystallization. The process we obtain crystal, that is called crystallization. So these things very easy. Okay. So students, crystal is a homogeneous solid of definite geometrical shape. Okay, it has symmetrically arranged smooth plane surface. Okay, of course it has a proper shape, just like you can see here cubic. Some crystal are or rhombohedric, some are octahedral, some are prismatic. So this proper shape, why different compound having these types of shapes, that you will learn in class 11. Class 11 solid state chapter is there in chemistry, senior class study. But here you learn that which crystal, which compound has, or which molecule has these types of crystal structure. Like you can see the example, sodium chloride has cubic structure, copper sulfate rhombohedric, and after that you can see ferrous sulfate, that is octahedral, and prismatic potassium nitrate. These examples are very important from exam perspective, so I think you make a note and you just remember this thing. Students, so crystal you learn it, it's symmetrically arranged smooth plane surface, and which meet forming a sharp edge. Okay, all the crystal has sharp edge, you know, these are the sharp points, sharp sides, so they have a sharp edge. Crystallization means um, process by which crystal of a substance form. So students, there is some process in laboratory how you can prepare crystal. First, by cooling hot saturated solution, means hot saturated solution of copper sulfate or ferrous sulfate or potassium nitrate or sodium chloride, okay, whatever, which will form crystal. Their saturated solution you will use and you will cool that, but it will take time. Okay, or you can use by slowing evaporation, slowly evaporating of a saturated solution. Slowly you will evaporate, and then after the complete evaporation, the substance left behind, that is the crystals. Similarly, third process by cooling a fused mass, and fused means, you know, melted mass, and that you, when you will cool, that melt will convert it, that fused will convert it into solid, and that will by this way crystal obtained, or by sublimation. Okay, so here you can see first that first process has explained how to prepare the crystal of copper sulfate. That basic thing I will explain, you read, you can easily understand. You know, in a general temperature, what you will do, you take a beaker and make a solution of saturated solution of copper sulfate. First you make a saturated solution, then what you will do, after making the saturated solution, that is suppose that is beaker, inside it is copper sulfate solution, just keep it one day, then you can see small bit of copper sulfate deposited below. It happens because when it will get cooled, some of its crystal will just suspend it down. Okay, it happens. So you just do one thing, you need to take one big crystal, which one is little bit bigger, take that crystal out and keep a rod over here and hang it, bind it in a rope and hang inside this liquid, that like this way. Okay, so that crystal is, this is called seed crystal, because student, what happened now, after you hanging this, after you hanging it, keep it 2 or 3 days, then it is a time taking process, student, 1 day, 2 day, 3 day. So after 2 or 3 days you can see that crystal become bigger. Why? Because just like magnetic induction, you know that one magnet, if you keep iron around the magnet, that iron also getting some properties of magnet. Similar way, that seed crystal, that crystal will induce the copper sulfate molecule present in the solution to induce that copper sulfate solution to attach on it, okay, to come and fall on it and make the crystal bigger. So after some day that crystal will be bigger and you will collect it, that is the copper sulfate pure crystal. That is the process of crystallization. So this process is called seeding. Here you can see the process including crystallization by adding a crystal of pure substance into the saturated solution is called seeding. Okay, so you know, to avoid addition of dust particle, you need to cover the whole beaker um, with the proper carton. Okay, you need to maintain these things. Students, now coming to the hydrated and anhydrated substance. Students, I will show my notes also. That pages will help you to prepare the notes. So after the lecture, in between the lecture, once I will show my notes also as well, so you need to follow it. Now come to the hydrated and anhydrous substance. Students, by the name you can understand, hydrated means presence of water molecule inside the compound. Here is the lots of example of hydrated substance. Generally we know they are called water of crystallization. Means a compound, suppose we are, you know, very easy example, blue vitriol, that one copper sulfate. Okay, it is available in market, blue color, that copper sulfate. Students, formula of, if you, in exam it will come that write the formula of blue vitriol. Okay, you will write copper sulfate, means you will get 0, because you need to write, you have to write 5H2O, means water molecule present on this structure of this crystal. Students, that is the complete structure of this molecule copper sulfate, because copper sulfate have water molecule and it is not the liquid water. It is, if you think that water is liquid, how, when we will take the copper sulfate it is to solid, but how the water molecule present? Student, this is called water of crystallization. Here what I supposed to read in the hydrated substance. So once again I am saying, hydrated substance means it has some water molecule in it. Anhydrous means no water molecule, that pure compound without any water molecule in it, that is called anhydrous substance. So hydrated substance has water of crystallization in it, that is the water which giving them the shape and also the color. Also the color, you just remember question used to come that which gives the colored copper sulfate, that is the water present in it. If you give heat, that crystal water will evaporate. Okay, you can see here the water of crystallization is in loose chemical combination. Okay, can be driven and can be driven up by as steam by heating 100 degree centigrade. Okay, then it will convert it into anhydrous. So normal CuSO4 you can see at anhydrous. Anhyd, that term you will be favorable. You have to see this term anhyd P2O5, anhyd H2SO4. Okay, so that are anhydrous potassium pentoxide. Okay, anhydrous silica gel. Okay, so these terms you will be very much well known in after senior in 1 or 2 year later you will be well known. So here you just need to learn that about the anhydrous substance. More or less I think you can understand. Now just come to the next thing, water of crystallization, it will give them the shape and the color also. Remember here you will read that in some cases it also give them the color. Okay, copper sulfate, question used to come that color of copper sulfate due to presence of water in it, and you have to write yes. Okay, so I think you understand. Here to show that hydrated copper sulfate crystal contain water of crystallization, here is the thing. You can see if you maintain this type of setup, that is a if you take a test tube and take some crystal of copper sulfate and you heat like this way, you can see drop of water is falling out, that is the uh, water of crystallization present inside the copper sulfate, which is moving away. Okay, that reaction happens. Okay, anhydrous copper sulfate and that water, and anhydrous copper sulfate color is white. Okay, when 5 water crystallization present in it, its color is blue. So students, moving to the next page, I hope you understand what is I will show my note also. Now coming to determination of water of crystallization, that is a process I will explain later. It is very easy also, not so hard. You need to calculate the molecular weight. Okay, molecular weight of the substance and molecular weight of the water molecule present in it. Then divide that molecular weight of water by total molecular weight of the substance, multiply by 100. That is the percentage of water of crystallization. Okay, means the I will explain later, no problem. Now come to the anhydrous substance. Anhydrous substance means no water present in that compound. Okay, here you can see, if you read this portion you can easily understand. Anhydrous is most often applied to crystalline substance when water of crystallization is removed. Anhydrous can also refer the gaseous form, some concentrated solution such as ammonia, and to distinguish it from aqueous solution form. Okay, so generally we know aqueous solution means water solution, so sometime we used to anhydrous ammonia, okay, or anhydrous some solution also we give the term anhydrous before it, because to make understand that there is no water molecule in it. Okay, that's why here you can see table salt is anhydrous sodium chloride. Okay. Gaseous HCl is anhydrous. Okay, so there is some process how to remove the water of crystallization, you know, direct heating, heating in dry air, heating under vacuum by using dehydrating. That is very nice thing, dehydrating and desiccating agent. Students, dehydrating agent are the compounds, some compounds are there which has the ability to absorb the crystal water of crystallization from a compound. Suppose copper sulfate has 5 molecule water of crystallization, so we will mix something that dehydrates. What the examples I will say, one you can remember, concentrate H2SO4, that is a that is a dehydrating agent. There is some other example also, I will explain after some time. So that if you add concentrated H2SO4, it will absorb the 5 molecule water, means chemically bounded water. Water of crystallization is the chemically bound with the, it is present inside their crystal structure. Okay, they can absorb it, that's why they are called dehydrating agent. So by using dehydrating agent also we can separate the water of crystallization. Okay, so students, I hope you can understand here everything, and here is some example of crystalline substance which do not have water of crystallization. Here you can see common salt, nitrate, okay, copper nitrate, potassium nitrate also known as nitrar, sugar, potassium permanganate and ammonium chloride. They do not have water of crystallization. So here now students, we directly move to the properties, means properties of hydrated and anhydrous substance. They are categorized, they have some properties when they are exposed to the air. Okay, there are they have generally three properties. One is efflorescence, another is delinquence, another is hygroscopy. Means that anhydrous and all these substances which has crystal water present on it, or the anhydrous also, they have these three basic properties. These three properties, students, I will explain by using my notes. Then after that three properties, there have drying and dehydrating agent. Okay, together I will explain in my notes. Okay, so follow it. So from here students, you can see water of crystallization. You can pause the video and you make the note. Then the next page, here efflorescent, delinquence and hygroscopy. So efflorescent means substance that undergo spontaneous loss of water. Means suppose you keep the substance in open air, then it will lose its water, that are known as the efflorescent substance. And the examples are washing soda, Epsom salt, etc. Washing soda, you know, sodium carbonate and 10H2O is there, so that 10H2O will just give up when it will keep in the open air. Okay, so that is they are known as the efflorescent. Okay, similarly students, the reverse thing, if you keep a substance, if some substance keep in the air which will absorb water from the air. Okay, air has the water in it, you know, and that much absorb and it will dissolve. Essentially the compound will dissolve, means you can keep this compound in open air, you always keep them in a bottom, in a tight bottle. Okay, in a tight you can say tight utensil, okay, with cap fit on it. You can't bring it contact with the air. If you bring it the contact of air, it will absorb the water molecule from the air, and it will eventually dissolve on it. The proper example you can say caustic soda, caustic potash, magnesium chloride, zinc chloride, calcium chloride, ferric chloride. Students, if you have the sodium hydroxide bead is present, I check that experiment, it is available in the market also. Some maybe you can't available you in chemistry lab, the in senior class you can perform, you can see that that bead of sodium hydroxide just like small naphthalene ball, and also if you piece the small naphthalene ball, it will look like that type of white. So if you take a bead on your hand, after some time you can see it will dissolve and totally it will melt down on your hand. Totally means it is so that is called this thing is called deliquescent. Okay, uh, deliquescent. The pronunciation is little bit awkward, so you just pronounce it properly, no problem. Not delinquent, it is deliquescent. Okay, or so that is the thing, that solid that absorb moisture from the atmosphere until they dissolve, okay, in absorb water to form a solution. These are the students, there is a proper example you can see, that table salt, not the good company table salt, they are not because they the impurities are not present, but if the some low quality salt also available in the market, okay, big crystal type salt struck is present, that salt, they will absorb water, okay, because of the some impurities are present in it, that is not due to the sodium chloride. Maybe you think that sir তোমরা দেখেছো শীত গরমকাল বৃষ্টিকালে এটা হয়, বাড়িতে লবণ কৌটোতে কি হয়, ভিজে যায় অটোমেটিক্যালি। সো এটা এয়ার থেকে ওয়াটার মলিকিউলকে টেনে নেয়, ওই লবণের মধ্যে কিন্তু সোডিয়াম ক্লোরাইড আছে, বাট সোডিয়াম ক্লোরাইড ইজ নট এ ডেলিকুসেন্ট, ওকে, বাট দের ইজ সাম ইম্পিউরিটিজ প্রেজেন্ট ইন ইট, ওই ইম্পিউরিটি গুলোই অ্যাবজর্ব করে, দে আর ম্যাগনেসিয়াম ক্লোরাইড অ্যান্ড ক্যালসিয়াম ক্লোরাইড, বিকজ ইউ সি ম্যাগনেসিয়াম ক্লোরাইড অ্যান্ড ক্যালসিয়াম ক্লোরাইডস আর দ্য ডেলিকুসেন্ট। সো ম্যাগনেসিয়াম ক্লোরাইড আর ক্যালসিয়াম ক্লোরাইড কিন্তু দামি কোম্পানির সল্টে থাকে না, তাই কি হয়, ওগুলো ড্রাই থাকে, ওগুলো কিন্তু ভিজে না, সিম্পল, ওগুলো শুধু পিওর সোডিয়াম ক্লোরাইড থাকে, অ্যান্ড সাম আয়োডিন মিক্সচার হয়ে থাকে, বিকজ ও তো সাম প্রপোর্শনে আরও অন্যান্য কিছু কেমিক্যাল হয়তো দেওয়া থাকে, বাট সোডিয়াম ক্লোরাইড, ম্যাগনেসিয়াম ক্লোরাইড অ্যান্ড ক্যালসিয়াম ক্লোরাইড থাকে না, দ্যাটস ওয়াই দে আর নট মেল্টেড। বাট ইমপিওর সাম চালু কিছু দোকানে লবণ পাওয়া যায়, যেগুলো কি হয় ফ্রম এয়ার থেকে কিন্তু ওয়াটার মলিকিউল নেয় আর ভিজে যায়, ওকে। সো দ্যাট ইজ এ প্রপার থিং, এটা তোমরা বাড়িতেও দেখতে পারো, দ্যাট ইজ দ্য থিং। নাও কাম টু হাইগ্রোস্কোপিক স্টুডেন্ট, সেম ক্যারেক্টারিস্টিক জাস্ট লাইক ডেলিকুসেন্ট, মিনস ওটা ডিজলভ করে না, কম পরিমাণে অ্যাবজর্ব করে। hygroscopic substance means they which will absorb the ওয়াটার মলিকিউল বাট নট ডিজলভ, মানে অ্যাবজর্ব করে কিন্তু অতটাও করে না যে ডিজলভ হয়ে যাবে একদম, ওর আইডেন্টিটি টোটালি নষ্ট হয়ে যাবে, অতটাও করে না, মোটামুটি করে, দ্যাট ইজ দ্য সলিড অ্যাবজর্ব ওয়াটার ময়েশ্চার ফ্রম দ্য সারাউন্ডিংস, ওকে, বাট নট ডিজলভ। আর ডেলিকুসেন্টের ক্ষেত্রে ডিজলভ করে দেয়, আর এফ্লোরসেন্টের ক্ষেত্রে রিলিজ করে দেয়, ছেড়ে দেয়, আর এরা অ্যাবজর্ব করে, এ প্রচুর পরিমাণে করে, এ অল্প পরিমাণে। The examples are concentrated H2SO4, which is also a dehydrating agent, and potassium pentoxide, phosphorus pentoxide P2O5, phosphorus pentoxide, and quicklime, which is called calcium oxide, and silica gel তোমরা দেখেছো নতুন বোতল কিনতে গেলে বা কোনো কিছু জিনিসপত্র, জুতোর মধ্যে ছোট ছোট প্যাকেটের মধ্যে ছোট 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 দানার মতো, চিনির দানার মতো থাকে, সেটাকে সিলিকা জেল বলা হয়। দিস আর লেখা থাকে যে ডোন্ট সোয়ালো, ওটা খাওয়া উচিত নয়, কারণ ওটা ক্ষতি করে শরীরে গেলে, দ্যাট ইজ কল্ড সিলিকা জেল, ওটাকে সিলিকা জেল বলে, ওর কোনো স্বাদ নেই, সুন্দর কাঁচের মতো একদম ক্রিস্টাল লাগে দানাগুলো, জুতোর প্যাকেট বা বোতলের প্যাকেটের মধ্যে থাকে, বিকজ কি করে, বোতলের ভেতরে যে এয়ারের মধ্যে যে ওয়াটার মলিকিউলগুলো থাকে, ও তো বোতলের গায়ে ছোপ ছোপ দাগ করে দিতে পারে বা নষ্ট করে দিতে পারে, কোয়ালিটি কমিয়ে দিতে পারে, দ্যাটস ওয়াই এই সিলিকা জেলের প্যাকেট দেওয়া থাকে জুতোর মধ্যে বা এরকম কোনো দামি জিনিসের মধ্যে, ওকে, বিকজ ইট ইজ এ hygroscopic substance and it is a drying agent, it will absorb the water molecule from the air থেকে নিয়ে নেয়। আর কনসেন্ট্রেটেড H2SO4 এটা হচ্ছে গিয়ে ডিহাইড্রেটিং, মানে ও একদম মানে মলিকিউলের ভেতর থেকেও বাউন্ডেড, যেটা কেমিক্যালি বাউন্ডেড ওয়াটার মলিকিউলকে টেনে নেয়। ওকে, ওটা আমি একটু পরেই এক্সপ্লেন করে দিচ্ছি। হিয়ার ইউ ক্যান সি দ্যাট ড্রাইং এজেন্ট অ্যান্ড ডিহাইড্রেটিং। ড্রাইং এজেন্ট ইজ অলসো কল্ড desiccants or desiccating agent, means all hygroscopic are called, all hygroscopic but not concentrated H2SO4, এটাকেও তোমরা হাইগ্রোস্কোপিক মধ্যে পড়েছো here. Okay, but generally all hygroscopic substances, okay, generally all hygroscopic substances are called drying agents. Like এই যে anhydrous calcium hydroxide zinc chloride magnesium, these all, okay, they will absorb the water vapor from the air. and dehydrating হচ্ছে গিয়ে কি chemically bounded water কে ভেঙে দেয়, যেমন এই যে কপার সালফেট থেকে এই 5H2O or এই সুক্রোজের ভেতর থেকে এই রিয়াকশনটা নেটে দেখতে পারো, দ্যাট ইউ জাস্ট রাইট দ্যাট রিয়াকশন অফ সুক্রোজ উইথ কনসেন্ট্রেটেড সালফিউরিক অ্যাসিড, ভেরি ইন্টারেস্টিং রিয়াকশন। দেখো ওয়াটার মলিকিউলকে বের করে দেয়, এর ভেতরে আছে সুগার, চিনি যেগুলো আমরা খাই, বা সুক্রোজের, কার্বোহাইড্রেট, গ্লুকোজ হতে পারে, গ্লুকোজ সুক্রোজের ভেতর থেকে যে ইয়ে থাকে, কার্বনটা শুধু বেরিয়ে আসে, 12 কার্বন, কার্বনের কালার ইজ, সো এটা সাদা পুরো ক্রিস্টাল এতে যদি হোয়েন ইউ মিক্স দ্য সালফিউরিক অ্যাসিড, কনসেন্ট্রেটেড সালফিউরিক অ্যাসিড মিনস ডিহাইড্রেটিং এজেন্ট, তুমি দেখতে পাবে চিনিতে করে কনসেন্ট্রেটেড সালফিউরিক অ্যাসিড দিয়ে দিল হুইচ ইজ কালারলেস, ও চিনি হচ্ছে গিয়ে তোমার সাদা, কিছুক্ষণ পরে দেখবি পুরো জার ভর্তি হয়ে গেছে, কালো হয়ে গেছে, বিকজ 12 মলিকিউল, দেখ এক মলিকিউল থেকে 12 গুণ তার কার্বন বেরোচ্ছে, মানে পুরো গ্লাস ভর্তি হয়ে যাবে। ভলিউম 1 গুণ চিনি ছিল, তার কিন্তু 12 গুণ হয়ে যাবে তোমার কার্বন। ওকে, অ্যান্ড দ্য ওয়াটার মলিকিউল বেরিয়ে যাচ্ছে, বিকজ এই যে কেমিক্যালি এর মধ্যে যে ওয়াটার আছে সেটাকে কিন্তু বের করে দিচ্ছে। সিমিলারলি এক্সাম্পল হচ্ছে অ্যালুমিনা, পটাশিয়াম, ফসফরাস পেন্টক্সাইড P2O5, ওকে, অ্যান্ড কনসেন্ট্রেটেড H2SO4, দিজ আর দ্য থিংস। ওকে, এটা হচ্ছে ডিহাইড্রেটিং মিনস কেমিক্যালি কম্বাইন ওয়াটারকে বের করে দেয়, আর ড্রাইং হচ্ছে নর্মাল জাস্ট। ওকে, so this is the thing students. So here I am once showing your book page drying, and this all I have explained. Okay, drying agent, desiccant, desiccating agent, you can see desiccant, these are also here you can see silica gel, quick lime, sulfuric acid, all the things. Dehydrated agent, that is alumina, phosphorus pentoxides, okay, that is the thing, and it is the last page. Last page means here the difference, I think you can understand. Okay, what is a desiccator, এটা একটা সাবস্টেন্স, দিস ইজ এ টাইপ অফ অ্যাপারেটাস, এটা এক প্রকারের অ্যাপারেটাস যেটা ইউজ করা হয়, অ্যানাইড্রাস ক্যালসিয়াম ক্লোরাইড রাখা থাকে, এখানে কোনো জিনিসপত্র রাখলে সেটা কি হয়, ড্রাই হয়ে যায়, ওর মধ্যে থেকে ওয়াটার ভেপারকে টেনে নেয়, কোনো সলিডসকে ড্রাই করা হয় এই অ্যাপারেটাসটা ইউজ করে, বিকজ ইউ ক্যান সি ক্যালসিয়াম ক্লোরাইড ইজ এ ড্রাইং এজেন্ট। হ্যাঁ, তো এখানে ড্রাইং এজেন্ট রেখে এই কাজটা করা হয়। সো দ্যাট ইজ দ্য থিং। Now student, next lecture I will explain all the things related to the soft and hard water. Thank you.